Hello there. My name is Yunus, and for the past 10 years, I have engineered and commissioned. That was like a helicopter, sorry for that. I'll do it again. Hi, my name is Yunus, and for the past 10 years, I have engineered, commissioned electric propulsion systems for marine vessels for both civil and military uses in Europe, Asia, and America. This goes from cruise vessels, ferries, I would say drill ships, military platforms, but today we are not here to talk about me. Today we are here to talk about a man who has inspired me so much in my journey of engineering, science, technology, and mathematics. Whether it's electricity that you are using, maybe the telecommunication that you are using to send your, to post your pictures, your TikTok dances, whether it's the mixer that you are using to prepare your smoothie. This man has pioneered almost all of these technological fields. It is with a great honor, and to be honest with you, with a lot of emotions, that I'm starting this journey of sharing my knowledge and experience from the past 10 years with you in science, technology, engineering, and mathematics, honoring the greatest inventor of all from his birth country. Today, we are honoring the one and only Nikola Tesla from his birth country. Welcome to the Mediterranean Sea. Welcome to Croatia. So let's understand how a ship works. So there is one thing that we can already agree on, and that is the propeller. I will draw it like this. So the propeller is the thing that rotates inside the water. So this is the water. Okay? So this is outside the ship. This propeller needs to be rotated, turned by someone, and that someone is the electric motor. Okay? So if we look at, so this is, I would say, mechanical energy, right? So it rotates. So here I will write little m. So this is the electric motor that consumes electric energy. So what we need here is something that produces electricity. So this motor can rotate. So because the ship is in the middle of the sea, you need to produce your own electricity. And to produce your own electricity, you need something called a generator. In fact, there are many. Sorry for my drawing skills. So you have a generator that produces electricity here. So all of these are electric energy. And now you need someone to rotate this generator. So you have chemical to mechanical, then the mechanical energy will rotate the generator and it will produce electricity, right? So you have electricity here, and then electricity here. So we found our source of energy. You could tell me, okay, we have electricity, so why don't you just draw a line directly like this? Yeah, just connect the motor directly to the network. Why add anything else? Here is the problem why. If you do like this, the question is, what's the electricity here and the electricity here? So I'm gonna give you the value here. So this one will be 6. Let me write it with a different color. 6.6 kilovolts, right? At 50 hertz, for example. So you have a 6.6 kilovolt here, and this motor here is only 3.3 kilovolts. So your first problem is that the voltage is not the same. Now let's even assume that the voltage here is 6.6 kilovolts. So you may tell me, okay, I have a motor, it's the same voltage, so I can connect it. Well, that's good. You have the same level of voltage. I'm gonna even make it easier for you. I will even say, let's assume the motor has 50 hertz. So in this case, you have exactly the same voltage. So in fact, you can connect directly the motor to the network, and that works. The problem of this is the following. If you do so, this motor can either rotate at zero hertz, so when there is no voltage, no energy, the motor will not rotate, and then when there is voltage, the motor will rotate. The problem of this, if you say this to the captain, he's going to become crazy, because a captain needs to, I would say, navigate the seas. So when the captain approaches the port, for example, then we enter a phase called maneuvering. So in this case, the speed can go between 0 to I don't know, anywhere maybe 40–50% of the speed. So we need something that varies the speed of the motor. And if you want to vary the speed of the motor, you will need to vary the voltage of the motor and the frequency of the motor. So that's why this one does not work. So what do you propose we put in the middle here? Because now we have even another problem. This motor is 3.3 kilovolts and the network is 6.6 kilovolts, so it's even not the same voltage. I will add you another problem. The frequency of the machine is not 50 hertz exactly as the network. The frequency of the machine is 10 hertz, 5 times smaller. So therefore, forget the problem of the captain who wants to vary the speed of the motor. You simply cannot connect this to this. I mean, you can do it, but it will not work, because if this machine has been designed for 3.3, if you connect it to a 6.6, the first problem you might run into it is the insulation of the winding of the machine. They will break, because this voltage is way higher than this one, so this machine will not withstand it. That's the first problem. The second problem is, if you give this machine 50 hertz, let's even assume the voltage is exactly the same, you supply with the same frequency, then this machine will rotate 5 times faster than its speed. Then the problem you will have is that one of the mechanical parts might say au revoir to you and leave. So that's a problem. So here's how it works. We have different level of voltage. So the first thing we need, something we call transformer. The symbol, the electric symbol of it is this one. Okay, so there is the primary side here and the secondary side here. Okay, between these two is like a galvanic insulation. There is no contact between the primary and the secondary. So the role of this, first of all, there are different types of transformers, like elevator, like the step up, step down, etc. So the one we are using here, as you can guess, is something that will step down the voltage. We don't want to elevate the voltage more, because the machine is 3.3 kilovolts, the network is 6.6. So this transformer will step down the voltage. That's good. Okay. The problem we have here is, now we have, let's even assume here we have 3.3 kilovolt now, 6.6. The problem you have at this moment is the following. This voltage is still a fixed voltage. So if you supply this voltage to the machine will rotate at a fixed speed. So what you want to do here is, you need, I'll go down to the machine, something called the inverter. Okay, inverter is AC, DC. The role of the inverter is the following, and I will do a separate dedicated video for it. The role of the inverter is the following. The machine accepts, let me go this side. The machine accepts a sinusoid, right? Something like this. That's the voltage that the machine accepts. So the component that will help us to do so is an inverter. I will put this symbol INV. And this is in fact a DC to AC converter. An inverter that will modulate the voltage here. It will modulate the amplitude, but also the frequency. Okay? Until now everything was AC. I will use this color. This was AC. this was also AC, right? Now we just introduced something DC. So this is DC. This is AC, right? And this is AC. This is AC. So we need something that will take us from AC to DC, and that is called a rectifier. Okay, so now we have DC. So this is DC, this is AC. So the symbol I just draw here, this is the symbol of a diode. Most of the rectifiers, what we call the DFE, diode front end, are made of diodes. Obviously there are other rectifiers made even, it's like an inverter but working in rectifier mode. But the most, I would say, affordable, the most standard in the industry are what we call DFE, so diode front end. Okay, and they are made of diodes. Okay, that's why here this is the symbol of diode. But again, I will make a separate video for this power converter, the rectifier, and also for the inverters. So then, as you probably have seen before, at the output of the diode bridge, we put a capacitor to smoothen the waves at the output of the diode bridge, and then your network is your architecture is done. You have DC here, DC, right? So the capacitor is DC. The inverter is happy, has its DC voltage as an input, is capable of producing an AC voltage at the output. Then we have the necessary voltage for the machine. The machine can rotate, and this is the fundamental basic architecture of a ship. It will be different for a car, for a train, but that would be the topic of another video. But this is the most fundamental one. So this has been said. I hope you enjoyed the video of today, and I'll see you next time for another episode.